Potentially exposure.
Yeah. Okay. Any? I think let's start. I'm just checking where am I here. Okay. Well, let's get started. If you have any questions, okay, just show of hands whoever attended at least one session from the previous two sessions. That would give me an idea as to who are new and who are not. Am I audible?
I was in one of the session.
Okay, first one or second one?
First one.
Okay, so first one was basically it went a little. I took it a little too fast, too soon, and second one was basically it covered a few basics. I am assuming some of you at least are familiar with the basics. If you need some help with the basics, there are a few people who have asked me for uh, doing that, covering the basics, and I'll cover that separately. So, please feel free to ping. Don't hesitate about that part. I'll take another session, a separate session from this ongoing session, a separate series wherein I can cover more basics. Right now, what I will be doing is I'll be covering some questions on conditional probability, and then I will give an essence of what a random variable is, because I think there were some questions from few people that they were not very comfortable with the idea of what is a random variable, what are the distributions, so on and so forth. And again, as I always mention, if you can, so if your bandwidth or your circumstances allow you, please do on your video. That helps me, interact better. At least I know who's asking the questions or who's not. Okay, so conditional probability. Sorry. Okay. Can someone tell me how do we know two events are independent? Just we are just trying to figure out what we have learned so far. What's the condition for independence of events?
P of A intersection B is equal to PA into PB. I mean,
Yes,
so isn't it?
absolutely. Fantastic. P of A intersection B is equal to P of A into P of B. If they are not independent, then how does this formula look? If they are not independent, then for dependent events, this looks as P of A intersection B is equal to P of A given B into P of B. Or this is also equal to P of B given A into P of A. Yeah.
Sorry, sir. Are you displaying anything?
Oh, I'm so sorry. So sorry. Yeah. Sorry. Let me know if you can see the screen.
Yeah, perfect. Yes, visible.
All right. So I just mentioned that if it is an independent event, then it is P of A into P of B. And if they are dependent events, then the formula is either P of A given B into P of B or P of B given A into P of A. Both are equally valid. And moreover, for independent events, P of A given B is essentially nothing but P of A. Intuitively, what it means is B has absolutely no effect on A, and that's why the probability of A, whether B happens or not, is the same. And likewise, P of B given A is equal to P of B. If one event is independent of other, the other is also independent of the first one. This is very, very strong intuition. This will help you. I mean, I'm trying to reinforce this multiple times because this will help you eventually. Now, there was, can you please go on mute? Someone is speaking. Please go on
Hare
mute.
Krishna, you go on mute, please.
Okay, so thanks. Now there was a problem that I saw. Someone had shared the notes today. Let me just see where are those notes. Yes, and I will put that over here. This is a problem that is there in one of your slide decks. I'm not sure which professor shared it, but this is one of the problems in your slide deck. And usually in your weekly tests or whatever, you get problems mostly from slide decks, right? So let's try to work this problem. A government agency has 6,000 employees. The employees were, I will ask the questions and I'll wait for the answers. And if the answer is wrong, that's absolutely fine. Try to at least have a go at it. The employees were asked whether they preferred a 4-day work week or a 5-day. So you have 4 days, 5 days, or flexible. And then you have male and female who were interested in each of those. Okay. What is the probability that a randomly selected employee is a man? Okay, first of all, I want you to answer me one question. What is being asked here? Okay, what is being asked here? In terms of notation, what is being asked here? This is the point.
Intersection of man, like a person being a man, and he's he's in favor of 4-day work. So that is M intersection 4 days, we can say.
So it will be 300 divided by 900.
It will be 300 divided by 900 is what you said. We'll see whether that is the right answer or not. But does everyone agree that this is the correct interpretation? The notation is correct. M intersection 4-day. Does have.
Yeah, so what we are saying is that is in favor of a 4-day week. So the population has to be those people who are in favor of 4-day week, out of which how many people are men out of them?
Okay.
But here one category of flexible is also there. So few men will be there in flexible category also.
No, let's not attack the problem right away. What I'm saying is my question is very simple. Do you first agree that this is the correct notation to answer the question? M intersection 4 days. The probability that a randomly selected employee is a man and is in favor of a. So how does and present itself in probability? Intersection.
What did you?
Intersection.
Right. So we have got this correct. We have got 4 days and we have got male correct. So we have to calculate M intersection 4 days. Right. This part is correct. Okay. Now, right away, where are you going? The randomly selected employee. Okay. How do we define probability? Probability is defined by probability of any event is defined by total number of outcomes, right? At the bottom,
yes.
Total number of outcomes. Okay. Now, we know for a fact that a randomly selected employee, how many total number of outcomes can there be?
6,000. Like
absolutely. Absolutely. This is the total number.
So this 6,000 is a sample size for us, no?
See, in this case, okay, that's a very intuitive question. In this case, this can very well become a population because you're just asking only that much, unless you are given a fact that the government agency has 6,000 employees and you have sampled each one of them, right? Give me just 1 second, please. Sahaj, can I just call you back and say I'm actually in a meeting? Is it very urgent? Acha, okay. ठीक है, done. Okay. Sorry about that. So 6,000 is essentially the total size, and because you are asking all the 6,000 employees, it becomes a population. And that question is very important because sample and population are very, very important terms, because your formulas for mean, not mean, but median and variance and everything changes because you have 1 by n minus 1 for most of them instead of 1 by n for population. I did not want to touch base on that, but because that question was asked, I'm answering this question. If you have any questions on this, I'll be taking a couple of other sessions, prelim sessions for few folks. You can join that to understand why it is 1 by n minus 1 for variance and for standard deviation. Okay. So this is a complete population right now. Okay. Now what we are saying is the answer is straightforward. The answer is you get 300 over 6,000. That's the total sample size. That's the answer because it's a man who's in favor of 4 days a week. So you get this one, and the total sample size is 6,000. But not all the time will you be given a table like this, and that is why you will not be given the table like this all the time. This is a very straightforward one. Okay, so we need to be able to calculate from our formulas, and let's try to do that. So that, okay, based on what I told you here, based on this formula, P of A intersection B is equal to P of A given B dot P of B. Can you tell me what P of A intersection M intersection 4D will be equal to?
300.
Sorry?
300.
No.
and
What I'm saying is convert this into a conditional probability formula.
Okay. In that.
Yes. Can someone tell me what will that formula look like?
Formula will be P of M by OD multiplied by P of OD.
Okay. P of M, which is male, given 4D into P of 4D. Does everyone understand this? What we have done here?
Yes, multiplied.
Right? Or this can all be also equal to, alternatively, this can also be equal to P of 4D given M into P of M. Right? I do need a yeses in terms of understanding. If you have not understood, please let me know. I'll explain this part again. Okay. The reason why I'm saying this P of M is because, okay, so now what is P of M? Just P of M. Probability of it being a male. What is the probability of a person being a male? Let me try to get this answer.
That's 1800 by 6,000.
1800 by 6,000. Okay. This is the total male population. And this is the total population. So 1800 by 1600. Everyone agrees here? So far, so good? Okay. And now, what we are saying probability of it being a 4-day given it's a male. And what is that value?
300 by 1800.
300 by 1800.
300, 400. So this is where, this is the line in which we are given that it's a male, right? So we have to choose only this part. Understand? We have to choose only this column because it's a male, right? So 1800 goes in the denominator, and we know that we are looking for 4 days, and which is 300. So it's 300 into 300 divided by 1800. And when we multiply these two, we get 300 by 1800 into 1800 by 6,000. And this is what we got just by looking at the square box, right? But as I said, you will not be given this square box always. So you have to be able to convert the problem into conditional probability. Is this part clear?
I have a doubt, Anup.
Yeah.
Why it is not 300 by 900 instead of 300 by 1800?
It is not 300 by 900 because then you would actually include female also. You are talking about this 900, right?
Right.
And your conditional probability is that given a male. Now, okay, so here this part will answer your question probably better. I said that you can use both the formulas, right? I used this formula. You could have used this formula as well. P of this is the beauty of conditional probability that P of A intersection B is equal to P of A given B into P of B. It is also equal to P of B given A into P of A. We chose
Either of them I can use, right?
you can use either of those. So now if I use either of those, then the value changes. P of 4D. Now what does P of 4D become? The probability of 4D, 4 days. What does that become now?
1200 by 6000.
No, not 1200 by 6000.
300 by
It is just 300 by 900. Exactly. This is 300 by 900. Right? P of 4D is equal to this is the 4-day thing. So you go across here. The total number of outcomes is 900 between male and female, and the 4D is the 4D that 4 days. Sorry, it's I'm so sorry. This is not.
It will be 900 by 6000.
900 by 6000. Okay, that is what the 4D will be. Okay, and male given that it's a male. Male given it's a 4D. Okay, what will that be? That is now 4 days go here, this straight instead of going here, and male is 300 out of the people who like the 4D. So you get 300 by 900, and this gets cancelled, and you get the same answer. I mean, what we got here, you got the same answer, 300 by 6000. Right?
Thank you.
Yeah. So the important question is the important point to remember here is not the diagram. A diagram, if you get it, you are very lucky. But if you don't get it, you will have to convert it into formula to arrive at the values. Okay. Okay. So the first one is clear. Is it clear for everyone? Do you want me to explain something again? What is the probability that the randomly selected employee is female? This is a very straight formula one. So what is the first? Tell me the notation for this. What are we talking about here?
Anand, just one thing in previous question. When we take male as 300, there will be few males in flexible category also who will be opting for 4 days or 5 days.
No. This is a clear-cut definition that 300 want 4 days, 1200 want 5 days, and 300 want flexible hours. It is not defined what those flexible hours
Okay, flexible hours period too.
These are categories, yes.
Okay.
Yeah.
Yeah.
Okay. So, okay. I'm not sure whether the professor worked out this problem in your session or not, because I took it from the PPT that someone shared today morning. Okay. What is the probability of a randomly selected employee being a female? What is being asked here? P of what?
4200
No,
divided by
let's
6000.
understand the notation. What's the notation?
P of F. P of F.
P of F. And now whoever was answering that, what was that thing you were mentioning?
So I was the same 4200
4,200?
divided by 6000.
Absolutely. 4,200 divided by 6,000. Right? So the number of females, total number of females are 4,200 and total number are 6,000. So P of F. And also remember P of M is equal to 1 minus P of F, right? Do we understand this easily, right? It should be because there are only two sections mentioned, so it should be that.
So, just a question here, like the probability of male, the formula that we have written, 1 minus P into bracket F. So, this is also one of the formula, right? The way we have written 4,200 by 6,000, the same way we can find out for male also, 1,800 by 6,000.
Yeah, it is P. So we actually, in this one, we just calculated P of M. We actually did that. In P of M was equal to 1,800 by 6,000, as we saw in one of the, when we did the conditional probability. So we calculated that. What I'm saying is this will be intuitively equal to 1 minus 4,200 by 6,000, right?
Okay.
So we know now P of F is equal to 4,200 by 6,000. Now, next question. A randomly selected employee turns out to be female. So we are saying now a randomly selected employee turns out to be female. Compute the probability that she is in favor of flexible hours. What are you talking about?
So this is the case of conditional probability where we have to focus only on female. That is a given part.
Okay, so how
And
do we
if-
how do I write it down as formula?
So this will be written as given female. That means P of flexible given female.
Absolutely. Does everyone agree with this part?
Yes.
Okay. And again, what is the formula that I should be using? I could use.
So it will be
Yes, like,
Subhajit, go ahead.
yeah, so it will be PF flex and female divided by the like the total observation in this case again.
Divided by,
That would
no, it
be-
is not. Remember this. This is the if you just
Oh, the female. Yes.
exactly P of female.
Sorry, sorry.
Okay. So when you say, okay, please keep this in mind. This is very easy way to remember the conditional probability. When I say P of A intersection B, or sorry, P of A given B, okay, it is the second part that either multiplies or divides. So when I say P of A given B, then it is P of A intersection B divided by P of B. Okay, the whatever is the given part, what already given, that is what divides it. And so whatever is the second part here, female, that divides it, right? Just so you keep this in the back of your mind, so that you remember the formula very easily. Now, flex, those who are flexible and those who are female, divided by P of the probability of it being a female. Probability of it being a female we found out already, right? What is the probability that it will be a flexible and female? Can you tell me?
Well, 2100.
2100 cannot be the probability.
And the female will be 4200.
2100 actually, what is the total sample size? The population size, what is the total this thing?
2400.
Flexible and female is basically out of 6,000. That is what we did. If you remember, that is what we did over here also, right? When it's a male, 300 divided by 6,000. That's the total sample size. Okay. So 2100 divided by 6,000 divided
But
by.
I have a question here.
Yeah.
Like, okay. So it's like PF in the below part that you are writing. Will that not be like 2400 part?
No, that is the total number of. So what you're saying is, if you randomly select some person, what's the probability that it will be a female, right?
Okay.
And
Yeah.
that is basically, if you you have 1800 male, you have 4200 female. So the if you choose them randomly, you will get 4200 divided by 6,000, right?
Correct.
So divided by 4200 divided by 6,000, and this is basically 2100 divided by 4200 is equal to 1 by 2. Is that okay? Understood? Clear? Any questions so far?
Okay, so because it's a conditional probability, that's why it's a 2100, which is a flexible, which we are sure about from the question.
Yes.
That we have picked up, and 6,000 in total, because we don't know exactly. I mean, it could be inclusive of male and female, and then we want to find out the female. That's why we have chosen 4,200.
Yeah.
I mean,
Yes. I mean, see, we could have gone. You are right. So 2100 out of the total size, we could have gone roundabout on this one and converted this flexible intersection female as another conditional probability of F given flexibility, right? We could have done probably a roundabout, a snake eating the snake's tail kind of a thing. But you are absolutely correct. It is 2100 divided by 6,000, because that's the Sorry, I actually wiped it, but if you remember, what is the probability that a randomly selected, this should give you an idea. I'm not sure whether you had joined earlier or not, but this is the one. Just read the first problem statement.
Yeah.
That is, a randomly selected employee is a man and is in favor of a 4-day work week, and that is basically 300 divided by 6,000.
Okay.
Right? Just because this is the intersection.
Correct.
Right? So that is the same thing that is playing over here. 2100 divided by 6,000. That's it.
Okay.
Okay. So that is that. I will probably not, can someone just tell me, other than probably Abhishek, can someone tell me what is the percentage of employees who's in favor of 5-day work week?
$2,700 by 6,000.
2,700 by
6,000.
absolutely. Right. So 2,700 divided by 6,000. These are people who are in favor, and that is their total, and this is the overall population size. Clear about this one?
Yeah.
Okay. So this was one problem I saw in the PowerPoint that you had. This was the PowerPoint slide that they gave. Go through this slide. If you have any questions, I will try to answer them. So as I said, not every time you will get. I hope you can still see my screen with the PPT that you shared. I just solved this particular one, and if you have any questions on this one, feel free to ask me. There is a tree diagram also, and that is why I said that you may not always get it in the form of what do you say, tables. You may still get it in plain simple words also, and tree is one of the very good ways to solve it. We'll actually solve a problem using that, and then I'll move to random variables and
From where shall we practice question for quiz or maybe exam?
I think for the slide for the unit test, the weekly test or whatever it is, your slides they don't deviate from the slides usually. Okay. I'm worried about Professor Shovan's. Professor Shovan actually passes everyone, so if that's a concern, then don't have that concern. But his question paper, you might have seen, it's a bit more involved than other question papers. He goes into the real showing what.
It's Professor Kapil for us.
Professor Kapil, I'm not sure. I haven't actually. Is he a faculty of IIM Kozhikode or a new person? Or something?
I think he was for PGP. This year he started.
Acha, okay. I do not have any idea about Professor Kapil. But his slides, whose slide was this? The one that I just showed you?
That was of Professor Shovan.
Yes. Oh, that was Professor Shovan. Okay. Okay. So, he will talk about marginal probabilities, joint probabilities, and this for sure he will ask you the questions around those.
Look, I have a question. Like the third one. Like, how do we decide that it is the female employee given flexible hours? Like, why not female intersection flexible?
That's where people mostly get confused, right? And it's a fantastic question. So you are asking, why is this P of flexible given female, and why it is not P of flex intersection this, right? Is this your
Yes.
question, right? What the difference is this. You have two events. One is flexible, one is female, two events A and B. What intersection talks about is this part. It just says that, this is when both the events happen, then that's the intersection, right? What we are saying is very different. What we are saying is, given that an event has occurred, so you know that an event has occurred. Let's say this is the event B. Given this entire event, it has occurred. Now you tell me what is my probability of happening, and that changes. In the last session, I had this. I'm not sure whether you were there in the last session or not. This is saying that we had worked out a very, very beautiful problem, which gave the intuition for this. Can someone, I mean, I know what I'm talking about, but anyone from the last session who can tell me what was that problem, that intuitive thing that explained the difference between these two concepts?
I watched the videos. It was like sum of 7 or 8.
Exactly. If an event can change the probability of another event, right? Then what happens is your sample size, sample space shrinks. You know, your total sample space shrinks. If I say that, probability of you have, sorry, you have a boy, you have a boy, girl. You have basically two children, and you know you have GB and GG. Okay, and if I say that what is the probability that both will be boys, then you will say this will be 1/4. Do we agree? What will be the probability that it will be a one boy and one girl? Then it will be 1/2. Why 1/2? Because it is 1/4 and this is 1/4. One boy, one girl, so they becomes 1/2, right? And what will the probability that is two girls? It is 1/4, right? All are equally likely except the fact that B and G and G and B, if we do not consider the order, it is that. Now my question changes. My question is, I am telling you that one of the child is a girl. Okay, then what is the probability that the other child is also a girl?
1/3.
Right? Given the one child is girl, then I've shrunk the sample space. Now this guy does not qualify at all. Right? This guy does not, and that is why it is not, I'm not saying P of G intersection G. I'm not saying that. P of G and G. I'm not saying that. This would be 1/4.
Okay, so given that she's a female, I have to understand that flexible hours, like how many.
I've changed the sample space for you now. So you have to consider only those samples in which your condition has occurred. Is that clear? Right? Any other questions, anyone? Okay. Now, there is one problem that I'll solve. This is from one of the books that I don't have it in PDF form, but I'll just read out the questions and. Okay, Joe is 80% certain. So Joe is 80% certain that his missing key. I'll just put the main things missing. I'm so sorry for my handwriting. Missing key is in one of the two pockets. So let's say left and right pockets, right? So left pocket or right pocket. Sorry. Being 40% certain, this is being 40% certain that it is in the left hand pocket and 40% certain that it is in the right pocket. If a search of the, okay, so now this, you have created a tree. If a search of the pocket, if a search of left hand pocket does not find the key, what is the conditional probability? Even if I do not mention the word conditional, it is conditional probability. What is the conditional probability that it is in the other pocket, that it is in right pocket? Does anyone want to take a stab at it? What it really means?
Anu, can you please explain the second part, like where you're saying being 40% in the left pocket and 40% in the right pocket?
So Joe is 80% certain that the missing key is in one of the two pockets, right?
Right. Yeah.
Then that means that first of all there is to be an arrow here wherein he is 80% sure that it is in one of the pockets, and he is 20% chances that it is not in the pockets at all, right? Do we
Right.
agree?
Okay, I got it. Yeah,
Okay.
that way you're saying.
And
The
out
tree
of,
diagram basically.
and out of those 40% he's very sure that it is in the left pocket, 40% is very sure in the right pocket, but that 40% is of the 80%, so it becomes 50%. So 0.5 is sure here and 0.5 is sure here. Do you see how I could have made a table out of it, I could have made a tree diagram out of it, but you will have to understand what they are saying, right? So you will have to become familiar with the conditional probability clauses. And it's a very simple problem. Once you if you just what am I asking? Okay, let's put it in formula. What am I asking? That is my question.
Probability of right pocket given it is not in left pocket.
Absolutely. Okay, so let's first put down few things. Okay, P of R. I'm not care. I don't care about what the values are. P of L. And if it is not in the left pocket, then what would it imply? How do I represent it? P
1
of
minus
P of L complement. It need not be one. P of L complement, right? Now I want P of R given L complement. Do we agree?
Yes.
Okay. And tell me the formula for this.
So it would be P of R and L complement
Yes.
divided by P of L complement.
Absolutely. Does everyone agree with this part? The formula? Yeah.
Can you please explain also?
Which part? This
This
formula?
complement part. This one.
Okay.
Yeah.
So if a search of left pocket does not find the key, so they are saying if the search of left pocket does not find the key, they have done the search on the left pocket, they did not find it. So does it become a given condition?
Right.
Right?
Because they have already
Yes.
reduced it.
Yes. So then the question is, what is the probability that it is in the right pocket? So what they are asking is, give me the probability of finding it in the right pocket, given you did not find it in the left pocket. And we established certain norms. We said that P of R is the probability of finding it in the right pocket, P of L is the probability of finding it in the left pocket, and P of L complement is the probability of not finding it in the left pocket. So I am asked probability of finding it in the right pocket given I cannot find it in the left pocket. Are we clear about the notation now?
Oh, yes. That means that we are making it a fair chance that we have not searched it on the left pocket. To denote that, we are using complement.
Yes. Okay. So now, here's another thing. Okay. P of R intersection left complement. Okay. If it is not found in the if it is not found in the this particular formula is basically nothing but P of R, because if it is not, sorry,
Is it the independent event? Like if it's not present in one, then in the other?
no, independent events would make it multiply, right? P of R into P of LC, isn't it?
Right. Okay. Yeah.
Isn't it? So the actually, if for independent events, if they are independent events, then P of R intersection P of A intersection P of B. What is the value for independent events?
It's a multiplication of both the this thing PR and PL dash.
Okay. Yeah. So now what I'm saying here, the point is that if you do not find it in the left, and you are in this branch, then you can only find it the intersection of. I mean, what is the other part? If it is Is L independent of R? Yes or no? If you find
Yes.
it in L, then you will not find it in R. I mean, they are mutually exclusive. I'm so sorry. They're mutually exclusive. If it is in L, then it is not in R, right? But if it is not in L, okay, if it is not in L, then it can only be in R or not at all. Do we agree? I mean, this particular part, R intersection left complement, is essentially reduced to P of right only. That's all, nothing else. Okay, and P of left complement on the bottom is nothing but 1 minus P of L. Is this clear? And this is basically P of right is the P of R that was there is 0.4 and 1 minus 0.4 is 0.6. So it is 2/3. The reason I gave you this problem is because it gives you the mental gymnastics that is required to solve conditional probability, which you will get. What Professor Shovan gave you, you should see his paper. I'll show you his paper actually. Give me a second. The one that I shared, I went through that.
Can you just explain the last part again, please?
1 second. I'll
This
just
1 minus P complement.
yeah, just a minute.
Yeah.
Okay, I'm just seeing which one is Professor Shovan. Give me just 1 minute. I'm doing that. I'll just explain it in a second. But if you see, you can see the question paper from Professor Shovan. Okay, here,
Yes.
if you see, what he does is he gives all the, not here, but he gives all the questions in regression studies. He will touch base on regression and everything a lot. And regression uses a lot of conditional probability, and then he will give you all the formulas at the end of it. Here, he will give you the formula just like that. Say use it. Okay. So you have to know when to apply it. That's a very important thing. Okay, now I'll come back to this part. Okay, you wanted to explain the P of L complement, right?
Yes. Yes.
Okay. So now here, P of L complement is essentially, he was 40% certain that it is in the left pocket,
Yes.
right? That means the everything else, it's either in the left or the right or the 20%, which is not there at all, right?
Right.
And this was basically, so this is 80%, 20%, of which 40% belong to this part.
Yes.
So the 1 minus P complement, left complement is, 1 minus P of L is essentially 1 minus 40%, only because it could have been in the right, it could have been not found at all. You have a distribution of 40%, 40%, and 20%. Okay.
Yes.
And anything which is not here is the complement. Do you agree?
Okay, so it was. But here we have taken the P of L complement. So in P of L complement, it will matter whatever is there, not there in L left pocket.
Yes.
That is 40% is gone, and also it will matter whatever is not there at all.
Absolutely. So P of L, this is P of L, isn't it 40%?
Yes.
Then tell me, what is P of L minus L complement? Just by percentage, just forget that. Just by percentage, what is P of L complement?
That will be a combination of 40 plus 20, 60%.
60%. 1 minus 40%.
Right.
Right? That is what it is.
Okay.
Okay, got it. All right. Okay, now let me. Okay, condition probability, I will not go much because no one shared me the notes from professor, so I do not know how much they have taught you on condition probability. I mean, I'm very sure Professor Shobhan had taught us Bayes theorem. I'm not sure whether he has taught you or not. So I will not touch base till you tell me that he has taught you. We'll move to what is known as random variable, right? What is the essence behind random variable and why it is used? And any thoughts, any initial thoughts on? Yeah.
So Anup, just one thing. What sir did, I think he didn't go through the Bayes theorem part. So in the probability part, yeah. So in the probability part, after conditional probability, he talked about the independence thing, like independent variables. Independence like like when A happened B equal to PA, wherein B has no
Yeah.
effect on the possibility.
I think we
So
covered
that
that in the first.
independence mean.
Yes,
Yeah,
we,
that is
we,
common.
we have
Yeah.
covered that already in the first two lectures, right? My idea was that before you hear from professor, he's fantastic here. So you should have an idea of what conditional probability is all about, what is independence of events. I hope that part is clear to you. If not, feel free. I mean, I can take multiple sessions. That's not an issue. Just feel free to.
But Kapil sir taught us Bayes theorem. He touched upon Bayes theorem.
Okay, so probably you all have the test coming up on when 21st, I think, right?
Ours is 18th.
We had on 18th.
You have on 18th. What about? I mean,
We have on 18th.
so if you have it on 18th, then for you Bayes theorem will not come, right? So what I will do is
Yes.
I'll touch base on Bayes because Professor Shobhan had taught us Bayes theorem. I know that for a fact. And Bayes theorem is very, very important for regression and everything. So he will teach you eventually. For other folks, please share Professor Kapil's notes so that I can teach you what he has taught you, and you can take care of them. Right? Give me that. Without knowing that, I cannot teach. I mean, I cannot tell you.
Sure, I will share that.
Yeah.
Great.
Okay. So now, what is a random variable? Is the big question. What's the problem with probability, or not a problem? What's the limitation of probability? Probability will tell you whether if I ask you, is it going to rain tomorrow or not, and you will look at the probability and you will say 80% chances that it will rain. I will ask you whether how many, but does it help me answer some of the more practical problems? For example, I'm in agricultural department, or I'm a farmer and I want to know how much rain will happen, right? So I'm not concerned about whether it will rain or not. I'm concerned about the of rain. Okay. Or I am someone who's a businessman and I want to know how many customers can I get today, right? Number of customers. Or else I'm a hospital and I want to know that, okay, these are my peak hours. In peak hours, how many patients can I get? And off peak hours, how many patients do I get? Because I can actually then put my staff and rotate my staff that way. Do you agree these are practical problems to be asked? Right? So now I cannot do that with a probability of rain tomorrow. I cannot do that. I have to ask, please tell me what is the probability that it is going to rain or greater than equal to 4 mm. Because that's 4 mm is a good amount of rain, right? What is the probability that I will get customers more than 10 customers, say at some hour, whatever it is, right? And how do I answer those questions? Those questions are
This is something we are assuming randomly, right? I mean, 10 number and 4 it's
not necessarily, because once you have basically what has happened is you have certain data, and that data is distributed in some manner. It could be distributed like this, it could be distributed like this, and in some manner it could be distributed. And let's assume that you call it 0th hour, 1 hour, 2 hour, and all those things. Then you have this data and you say, okay, you know what? More or less, I will get the same number of customers that I've been getting historically. So you have a distribution. So there's a distribution there's an underlying distribution. Okay, I'll give you another example. Now, okay, I just want 4 or 5 of you just tell me which field you are from. If your field is repeated, please do not answer. For example, if someone is from IT, from software, please do not repeat it. If yours happens to be saying, I just want to get 3 or 4 different industries. I just want to understand where you are from. Give me 3 or 4 answers.
Yeah, I'm from consulting.
Okay.
Yeah, I'm also from consulting.
Banking.
Banking. Okay.
Manufacturing.
Okay. Fantastic. I've got 3 answers. Right? Sorry. Did someone say farmer? No. So now in manufacturing, you want to know number of defects.
Right.
Likewise, in what was the other industry? No, not the consulting one. What was the other industry someone mentioned? Banking.
Just banking.
Yeah, in banking. In banking, you want to talk about loan default. Okay. These are you will give certain parameters, and you will ask what are the chances that the person can default, and those are the probability questions. Those are the random variables over which you will ask those questions. So, for example, I am saying that you have a die, so you get 1, you get 2, you get 3, you get 4, 5, and 6. 6 values you get, and I am asking you a question. X becomes an event. An event can have we represent it as P of X equal to some A. How is this different from P of A? It is different from P of A in the sense that X can be a group of outcomes, whereas P of A is a single outcome. That's the all difference between the random variable that we choose. So X can represent a group of events. A group of event could be when I say, tell me. So do we all agree? If it's a fair die, then your chance of 1 is 1 by 6, and so on and so forth till 6. Do we agree with this part?
Yes.
Okay.
Yes.
Did any one of you actually do that experiment and see that it is true? No one did it, right? When we flip a coin, right away, if we flip a coin and we get a head, then there's no guarantee that the next one will not be head, and you will not be able to concretely say you get 50% heads and 50%, so chances are 1 by 2. You cannot say that, right? Do we agree? What it really means is, if you keep on increasing your trials, then eventually you will settle down to somewhere close to 1 by 2 probability. You will get 50 heads. If you toss 70 times, chances are you probably get 40 heads and 30 tails. And you will say, no, that does not fulfill 1 by 2 thing. Make it 700, you might get closer to, let's say, 340 and 360. And make it 7,000, and you probably will be equal to 3,500 and 3,500. I mean, that is the whole point of probability. So the distribution which demands it, which calls for it, is what is known as a random variable. Now, when I say P of X equal to A, I can also say P of X greater than equal to, say, 4. What I'm saying is, what is the probability that I will get a value which is greater than or equal to 4? How does it translate? Please tell me, I'm a farmer. Please tell me that the amount of rain I'm going to get tomorrow will be greater than equal to 4 mm, because then I will have to put some barricades to prevent prevent the flooding in my fields or something else, right? And that is what you cannot answer through just probability part. You cannot say probability is at a point, right? Probability is of an event. But do you get a sense of where the random variable comes into picture? Any questions on this one?
So is it that the random variable will work for a complete range?
Yes, depending on how you define the event, you can actually define your event in multiple ways. See, and the point is this. We'll take an example. You have boy, 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 girl, girl, boy, and girl, girl. Okay. And my event I'm defining is, I'm saying the event is defined on it being a girl. So X is equal to 0 means there is
Only boy.
0 girl, right? No girl. And that is how much?
1/4. 2/4. 1/4.
So now my event is defined as that. This is how I've defined my event, that X is number of girls. I've defined the event over the probability. This is the probability distribution. And I've defined the event over it, right? So now when you add them up, add all these events up, X equal to 0, X equal to 1, and X equal to 2, you should always get 1. Right? I could have defined my event in some other way. I could have defined, let's say I am saying probability of X is equal to no, not in this case. I will have to take it in the case of probably a die, not in this case. Give me a second. I had thought of an example for this particular part wherein I can define my event in a separate thing. I'll probably get back to you. So it's skipping me. But did you understand the concept behind the random variable right now? What random variable is? We'll go into the problems of it later on. But did you understand? Is the concept clear? What random variable is? Okay. Now there's a very important thing. So random variables. Okay. One important aspect of your question was, is it over the entire range? Yes, it is over the entire range. There are two different types of probability distributions. One is discrete. So discrete random variable, and another is continuous random variable. We'll see what it means. They both sum to 1, but a discrete basically is, this is a discrete one. This is a discrete one, and the rain example is a continuous one because it can be 4.234. There is no particular point in which I can do that, and there are certain very good implications of this and of continuous random variable. But we will not discuss that right now. Okay. There is something called expected value. This you are supposed to do. This is something which you will use almost everywhere. What is an expected value? Expected value is very counterintuitive. It is the value you expect when you run the trials multiple times. Okay. So you throw a die. P of 0 is 1/6. I'll just write it down because of P of 1 is equal to 1/6. So on. P of 6 equal to 1/6. Can someone tell me what's the expected value? If you know it, do let me know. What is the expected value of throwing a die?
Mean.
Expected value is also known as mean, though they are not both exactly same. But what is a mean? How do you calculate the mean?
Summation divided by number of events.
Okay, so let's calculate the mean. Summation divided by, tell me, what do I sum?
I think weighted mean, like 0 into 1 by 6 plus 1 into 1 by 6.
Yes, that is the expected value. So expected value is your x into p of x. Note I'm using small x here, right? So you get 0 into 1 by 6 plus 1 into 1 by 6 plus 2 into 1 by 6 plus so on 6 into 1 by 6. Why is 6 there? There is no 0. I'm so sorry. This is 1. Okay, so this answer will be 3.5. You can check it. Now, what does it mean? You will not get a 3.5 when you throw a dice, right? You will just not get it. What it means is if you continue throwing a die multiple times and take an average of that, then the expected value is going to be 3.5. What it means, where it is useful is if I observe the rain over a period of certain months, then my expected value is something. If I observe how many customers are going to walk in, if I observe the number of customers or the number of patients who are walking into the hospital and average them out over a long period of time, I might not get a complete what do you call it, an integer number. I might get a fraction number, but it could be 11.2, it could be 12.5, but that is the kind of amount, that is the kind of number of patients I'm going to receive, and so I can plan according to that. Expected value, they will teach you very shortly because you cannot learn about random variables and all those, distribution functions without expected value, because expected value, variance, and all those things are the formulas that you will be using. So is this part clear now to you? What is expected value? How do you calculate it?
Yes.
Any questions so far? In any of the things that we discussed so far, because day after tomorrow we'll be looking at we'll be going further into distribution functions. So let me know if there are any other questions or any basic questions. It's okay. Tomorrow I'm taking